Okay, so welcome. Instead of Mr. Hartz's voice today, you get Mr. Laux's given a shot for day 8, where we're doing now two tangent lines intersecting outside the circle. We've done a bunch of different combinations of secant and a tangent, sometimes inside the circle, sometimes outside the circle. But today, the general view will be something like this and this, almost looking like an ice cream cone, where we have an arc measure up here, an arc measure here, complete that a little bit, and then we have some kind of angle down here that we're trying to solve for. So just as a quick review, little do now, if we were to look at this one on the left, we know that when a secant line here and a tangent line intersect, obviously the tangent line intersects on the circle right here at point A. And so we have this kind of inscribed angle right there. And we know that if this inscribed angle is 78, our formula is for an inscribed angle, whether it's two lines intersecting on the circle, or in this case a secant and a tangent line, we know our formula is bend or arc divided by 2 equals my angle. Okay, that's a little thick, so we'll change that. Let's see if that's better. So in this case, I don't know my bend. I know that I would divide it by 2 and I'd get 78 degrees. So x would be 78 times 2, 156 degrees. So the measure of angle A, or arc rather, bend AB, this one here, that measure is 156. Obviously then we could take for ACB, so going around this way, ACB, right, would be 360 minus the 156, which would be 204. Okay. So that should be a little bit of a review from a couple days ago. And then over here on the right, we've got a secant here and a tangent line here, and they intersect outside the circle. So the first example was on the circle, over here, this one. But right here, we're intersecting outside of the circle. And our formula then is, again, my bend minus bend over 2. So for here, we have 220 minus the 40 over 2 equals 180 over 2, which is 90 degrees. So angle X here would be 90 degrees. Okay, so just a quick review. Now we're going to move on to a problem like this, which I will zoom down. Maybe zoom quickly, view, zoom 50%, 75%, so you can kind of see it. But the idea is here we have this arc, 220, and this arc, 140, and the question is, what is x? And there's some examples over here. You could maybe take a moment, hit pause, and guess what you think x would be, perhaps using some of the formulas that we have so far. Hint, this one on the right here. So going back here, let's see if we can prove this. So view, zoom, go back to my page width. So if we were to label, make sure I'm the smallest. If we were to label this graph here, you see that we've got a tangent line that intersects at A here, a tangent line over here that intersects at C, intercepts the circle, or rather touches the circle. They intersect down here outside the circle, creating this angle X. Okay, and then I just drew a line, dotted line, right here going through point D and B, and we could kind of use what Mr. Hartz proved the other day to expand it to two tangent lines. So right here would be like kind of a tangent and a secant, and so we've done that. So that formula would be AB, arc AB, minus arc AD over 2. And that would give us this. In fact, I should write it over here. Just this part right here would be AB minus AD over 2. And then similarly, let's write it in red. This angle right here would be this arc, so BC, BC, minus this arc, DC, over 2. Okay, and obviously this whole angle X, maybe I should do that in green. Mr. Hartz will hate this because he might not be able to see all these colors, but this one right here would then be the sum of those. So if I could rewrite this in green, X is going to equal this angle measure plus this angle measure, right? So we've got AB minus AD plus BC minus DC, these are all arcs, all over 2. Well, if I look at AB and BC, that's just this. A plus B plus C is just ABC. So arc ABC, which is my big arc, minus, now I look at this, I'll maybe put this in red. Again, you could replay this video if I'm going too fast. This plus this is going to be this angle right here. So go back to green. And we've got minus arc ADC, that small arc, over 2. Okay, so this is my formula for when we have two tangents. The big arc, in this case ABC, minus the small arc ADC divided by 2. So let's try a couple of examples really quick. Again, this is a little too big. I apologize. Let's go zoom 75%. That's better. So if we look at this, we know our formula for X. X would be big arc 240 minus 120 divided by 2. That's going to give me 120 divided by 2, which is 60 degrees. So this X is 60 degrees. That's one example. What about an example like this? At first, you're kind of like, wait a minute, I don't have any numbers. I have this 38 degrees, but I don't know this small arc and this big arc. So maybe pause and think for a minute what we do know. If this is X, what is this arc right here? Well, that's 360 minus X. Okay, so now we can use our formula. I'll write it off to the right here. It's not going to write right there. We'll write it right here. 360 minus X again, divided by 2, and that should equal 38 degrees. Okay? So if I cross multiply, and I'll put it down here, 38 times 2, I believe is 76, equals, simplify up here, 360 minus 2x, right? Minus x is minus 2x. I'm going to add the 2x to the left. 2x equals 360 minus 76 is going to be 2, oh boy, another 16, 84. 60 plus 16, I think that's right. And then x is going to be 142. So this would be 142, and then this bigger arc would be 360 minus 142, So let's check that. 360 minus 142. So this arc right here, if x is 142, this one must be 360 minus 142 minus, which would be, let's see here, 36 minus 14 is 22. So 360 minus 142, borrow, and get 218, so this has to be 218. Then we can say is 218 minus 142, that is going to be 76, and then 76 divided by 2 gives us 38. Okay, so I'm doing the math right alongside you guys. Last example. Here, the only thing that's different is where my x is. X is up here. That's fine. That means this is 360 minus x. So once again, our formula, though, is our big arc. This has to come first. So the 118 degrees has to equal my big arc, x minus 360 minus x, all over 2. So if I extend my page, will that work? I'll look at that. 118 times 2 is going to be 236 equals x minus 360 plus x. Remember, negative times a negative is a positive. So now I've got 236 equals 2x minus 360. I got to add 360, so that's going to give me 596 equals 2x. And therefore, x equals, well, 600 divided by 2 is 300, so I need 298. 298. So this is 298. That means this arc right here must be 360 minus that, which would be 62. And if our formula holds, well, 298 minus 62 is 236. And I take this divided by 2, I get 118, which is what my angle is. Okay? Hope that makes sense. Feel free to rewatch or pause, and definitely send an email to either Mr. Hartz or myself if you have questions. Hope you all are doing well. Bye.